Hello guys, welcome you all for this end-to-end session. Okay, where you guys gonna learn everything that you guys need to become a successful data scientist. Hope you guys are enjoying the session. Like we are enjoying a lot and we are learning a lot. So today is a continuation session of previous session where we are learning about the data science life cycle. Hope you guys like enjoyed all this video, all these sessions. So if you guys are not watched any of the previous videos, please make sure that you watch all the previous videos so that you can have a better understanding of what we are seeing now. So today we will be continuing the session which we have done previous day, which is on data science life cycle. Okay, so yeah, without wasting any time, just jump into the session. Yeah, feature engineering selection and selection. Okay, feature engineering and selection. Let's see what we are having in that. Okay, so yeah, I hope like if you guys have watched all our videos, now you guys are well versed with what is meant by feature engineering. Okay, like whenever we are having a older data and we are creating a new data out of a older data, then it is called as feature engineering. Okay, this new data which will be very helpful for us in order to work on in order to predict the target values. Okay, that's a major thing. That's a base thing that we will be telling. Okay, let's see what we are having for this feature engineering and selection based on this topic. Okay, feature engineering create new features from existing ones or deriving them from domain knowledge to improve predictive power of the model. Okay, right. So actually I have mentioned this example previously. Let us consider we are getting a data like voltage and current, and we are having some target value. Okay, now we need something called as power in order to predict the target value very accurately, but we are having only voltage and current. How we can do that? We can create a new feature using voltage and current. There is a formula called as P is equal to VI, that is voltage into current, which gives the power. Like that we will create a new column which will act as a accurate, or we will say optimal. Okay, optimal column or optimal value in order to predict the target variable. Okay, so now you guys can understand, right, how we can create a new feature. Okay, now feature selection: select the most relevant feature for the model based on their importance, correlation, and contribute to the prediction. Okay, okay, so consider like we are discussing about that hard disease prediction data set, right? We will be having 15 features. Whether these 15 features will be helpful for us to find the target value of whether the patient has the heart disease or not? No, right? There will be some unnecessary features which will not gonna contribute that much to the target value. We can remove that. Okay, based on the correlation. If it is as a negative correlation or some kind of no correlation, then we can remove that. Okay, so that is what the feature selection. We doesn't require all the 15 features for the prediction of the heart disease. We just require at least 5 to 10 features in order to predict the heart disease based on that. Okay, so you need to go for a feature selection. So what this time we'll be doing means we can avoid overfitting problem. Okay, whenever you are having more features, there will be a possibility that model will learn each nooks and corners, so it becomes overfitted rather than of generalizing. Okay, next. Feature transformation: transform the feature into suitable form for chosen models, algorithms such as scaling, normalization, and encoding. Okay, I will tell an example for this. Consider you are having a two columns, right? One column you are having a single digit number like 1 to 9, 0 to 9. Consider 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in another column you are having a 5 digit number like uh, like uh, consider we are having 5 1s, 5 2s, 5 3s, 5 4s, like that you are having a 5 digit numbers. Okay, as a human you say that what is your most priority numbers? Okay, whether it is a 1 digit number or a 5 digit number, it will be the 5 digit number, right? The model also thinks in a same manner. It will give more importance to the 5 digit number only. That time what happens means we will ignore this 1 digit number and we will thought 5 digit number is a very important in order to predict the target. So what happens means we will go for a bias kind of thing. Similarly the model will do. So that time what we will be doing means we will apply the scale over the data set. Okay, we will make all the data in a same scale, like the 1 digit number also becomes the same scale, and then 5 digit numbers also become a same scale. The most used technique is a standard scalar, where we will be scaling all the data to 0 to 1. Okay, the 1 digit number will be moved on to 0 to 1 scale. Similarly the 5 digit number will be moving on to 1 to 0 to 1 scale. Okay, now all the data will be 0 to 1 scale. Now as a human, okay, all the data in the same scale and we need to consider in the same form. Model also thinks in the same way. Okay, all the data in a scale of 0 to 1, and we need to consider in the same form. Okay, this is what scaling, and these are the feature selection techniques, guys. Features engineering and selection techniques, guys. So hope you guys have understand this. Yes, sir. Over to you.
Yes. So feature engineering and selection. So we already have reiterated what is feature engineering. So if you have come to this session, just go watch previous session 5 to 10 times, do reinforced learning, absorb the information, digest the information, apply the information, do all the assignments, then come here and subscribe to our channels, press the bell icon so that you will get notification for each session. Feature engineering, it creates new feature from existing ones. Okay, this is very simple. So I'll give you example. Suppose you combine milk and lactobacillus bacteria into milk, you get curd. Or you put lemon in milk, you get uh, cheese or paneer, whatever. Huh? So you boil that milk for a long time. You put that you keep it for some time, and then you boil. You'll get ghee. So it is there in your life, but you have to observe these things. That so we are creating from existing data. We are creating new features. Okay, that's at that. I'm making it very simple so that you can remember. And it drives them from the domain knowledge to improve predictive power of the model. So see, once you have different features, so I'll tell you how it will help. Feature engineering helps you to identify hidden patterns, guys. How? Because when it will create different kind of features out of existing data, it will do lot of correlation and it will give you insights, and it will make decision based on that. So what can happen, possibly what can happen in the future for this particular objective function, whatever you model you are building. So what can happen, it will show you possibilities. That is what you want to know as a data scientist, because proactively you will take measures and control, and you will create a policy, and you will have control system, and you will have a system which will not impact if there is a possibility of something happening like that. This is very powerful. Then feature selection selects most relevant feature for the model based on their importance, correlation, and contribution to predict. See, what I said in the first go in feature engineering, that's what is feature selection. Because it will do that, because it will find the relevant features based on the importance and correlation and contribution for prediction. Why prediction? So that whether model or we as a data scientist, we make decisions. So the model will make decision and predict according to that, and that is why it is very important. Then feature transformation transforms feature into a suitable format for the chosen machine learning algorithm, such as scaling and normalization and encoding. So here we can do feature transformation so that we will be we'll choose machine learning algorithm such as scaling, normalization, and encoding. This is how we'll do data like feature transformation into a suitable format. So this is how feature engineering and selection works, guys. So this is very, very, very important. You can apply feature engineering in any domain, I'll say, if it has data. So it's not only machine learning in AI and data science. You can, because of that, you will see in biotechnology, you see they created that sheep called Dolly because of hybridization, like mutation. And that is what is that is feature engineering, because they, from the existing genes which already normal sheeps had, they created new ones, and then they created the healthier ones, and then you will see the meat is very good, like it's very it's very healthy because of that. In biotechnology it is done, right? And other and life also, we have only four basic DNAs, guys, in our body, but then see the mechanism and how many combinations and permutation combinations we have. And that, so you can see everywhere in life feature engineering, you just need to observe. And in data, definitely, so you can bring those ideas into data. And data is not only numbers, guys. There are different forms of data, and data is live, because how it is live, because it is changing every time. You can see you will never have a constant data, because time series is changing. Time series is changing, and data is definitely changing. It's live, it is continuous. So we need continuous data scientists, AI ML engineers, AI researchers, to build different kind of models, continuously find solutions for the problem. It's a continuous thing. You just need to learn principles, methods, and models and concepts deeply. Okay, let's move to the other section.
Yeah, sure, sir. So moving on, what we are having? Okay, model building and evaluation, guys. I think this is also a major thing. Once you build a model, you need to evaluate it. Let's see what are the things that we are having. Model selection. Choose an appropriate machine learning model based on the nature of problem and the data characteristics. Consider factors such as accuracy, interpretability, and computational complexity. These things are very important. You need to choose a model which is best suit for your data set. You doesn't need to choose all the models because you will know everything. Okay, now I think after 3-4 sessions we're gonna learn, jump into machine learning, where you're gonna learn, like, I think nearly 10 to 20 plus models. Okay, after completing that, you guys gonna have 20 plus models ready for you. Not that you guys gonna have all the 20 plus models so that you can apply all the 20 plus model to data set. No, not like that. You need to understand what is your business needs and what is your data need. Then you need to apply the appropriate model to the model to the data. Okay, you need to know what kind of problem statement it is. Okay, in machine learning we have taught, right, whether it is a classification, regression, or it is a clustering problem, association. Based on that, you need to select the model, and you need to incorporate that model for the data. Like that, you need to go for model selection. Model training. Train the selected model using the prepared dataset. This involves adjusting the model parameters to minimize error and improve its predictive performance. Yeah, that's true. While training, you have selected your model and you have a dataset and you started to train it. The major thing is that you need to tweak the parameters which is present in the model. Okay, that is what the major thing that we can do. That is what the, I will say, that is a maximum thing that we can do, because like there is only 2 lines of code, guys. You guys gonna not believe, but like I hope like after 2-3 sessions we gonna have a every day, like in an alternative days we gonna have a coding. That time you guys gonna believe that okay, there is only 2 lines of code. We can only able to tweak the parameters which is present inside the uh, model. Okay, like hyperparameters. Okay, so you need to tweak that, so in order to get a better model. Then model evaluation. Assess the trained model's performance using various metrics such as accuracy, precision, recall, F1, and area under curve. Evaluate the model's ability to generalize to the unseen data. So once you train the model, give the unlabeled data, like sorry, unseen data, okay, which the model is not trained on, and you need to predict whether the model's accuracy is somewhat which is closer to as we expect. Okay, it is not like 100% is good, 95% is good, 60% is wrong. Not like that. You need to make a model optimal model so that you can work on it. Okay, that's what model evaluation. Model tuning. Optimize the model's parameters and hyperparameters to achieve the best performance model. This may involve techniques like grid search, random search, or uh, Bayesian optimization. Okay, I hope like these are the terminology that you guys gonna learn in a practical manner. So model tuning is that consider you getting a 60% accurate model, and you need to tweak it, right? So you need to majorly, you guys need to tweak it so that you can get the best performance model. That's it. Okay. So yeah, this is a major thing that you guys need to do once the model is built. Okay. So you need to select the proper model for your data. You need to train the model, selected model for your data. Once you are trained, you need to evaluate the model using the unseen data. Finally, you need to tune the model so that you can get the best performing model for your data set. Okay. Hope you have understand this. Yes, sir, over to you.
Yeah. So, guys, we have to understand that we have to do all the previous steps properly so that we reach building models and doing evaluation. So, model selection, we have to choose appropriate machine learning model. So, according to the characteristics of the data and the problem statement, and you have to take these two considerations, okay? Accuracy, the other factors like accuracy, interpretability, computational complexity, time and space complexity, a lot of things, okay? And even budget constraint, time feasibility stuff. So because a lot of models will learn, it will take a lot of time, huh? So you have to understand that how much, and also computational complexity, which is already there. So model training, we have to train the model, and we have to on the prepared data set which is already pre-processed, okay? So this involves adjusting model parameters to minimize errors and improve the predictive performance. So then we have model evaluation. We assess and train the model's performance using various metrics such as accuracy, precision, recall, F1 score, okay, and areas under curve like AUC evaluation, evaluate the model's ability to generalize to unseen data. So it should not be biased. So if it is generalizing well, then your model is good. So because ultimately you need a model which generalizes well so that it can see the unseen data, okay? Then model tuning, optimizing the model parameters, hyperparameters, and achieving the best performance. That may involve techniques like grid search, random search, or Bayesian optimization. So model tuning will optimize your model properly, okay, using different techniques. It also depends on what kind of model you have. So based on the characteristics of model, and model depends on the characteristics of your problem statement use case or the data characteristics, okay? And then according to that, you have to train the model when you select it. Then you have to evaluate the model using different techniques according to the model. It is always according to the characteristics of model, and training is done according to the characteristics of model. Model evaluation is done according to the, because then there is a hierarchy. Model is selected according to the problem statement and the objective function and the data characteristics. And then model selection is done based on that. Then model training is done according to the model. Okay, it becomes very specific, step by step. Then you have model evaluation according to the training and the model. And then model tuning according to the model and the evaluation and the training. So it is completely a systems thinking which is happening here. If you see end to end, which is very important to do synthesis. It is not a unidirectional system. It is a synthesis. Different concepts, different techniques, different aspects, different factors, objective function, your understanding, domain expertise, lot of factors are there combining and making synthesis kind of system, and which will be helping you to build a great model. Okay. Yeah, that's it. Let's move to the other section. Thanks.
Yeah, sure, sir. So moving on. Okay. Okay. This is what the final goal be, guys. And okay. So whenever you are having a model, you need to deploy it and start to monitor it. Okay. Whenever a problem statement is given to you, our step, our thought process is to, okay, so we need to successfully deploy something and we need to get revenue out of it and we need to monitor it. Okay. So this much way we need to go through in order to go to the step of deployment and monitoring and getting monetization. Okay. So guys, I hope like this is a simple step when compared to the all steps we are doing. Okay. Data acquisition, data cleaning, EDA, model building, evaluation. Compared to all steps, this deployment and monitoring is not going to take that much effort from me. Okay. I'm pretty sure. Okay. Yeah, let's see what is that. Model deployment, deploy the trained model into a production environment for real-time or batch prediction. Choose a appropriate deployment platform based on the project requirements and then scalability needs. Okay, there are different platforms available. There are different clouds available. Google, Azure, and then there are something called as Microsoft. They also provide Azure, and then Amazon they provide EC2, like those things. Okay, you need to choose what is a better performing cloud service for you, and you can deploy that. Okay, there are free cloud service also. Like there is something called as Hugging Face where you can deploy your model. But like you guys need to fix, and you and your client should have a proper understanding of what we need to deploy and where we need to deploy, how safe the model should be and the data should be. Based on that you need to deploy, because like if you are going for a third party, right, they're gonna access your data, because unless and until we have a data, we will be training the data in a local way and we will be safeguarding our data. End result is we need to deploy somewhere. We should have a confidence that the deployment platform will be very much confidential with our data, with our client data. That kind of platform you need to choose and you need to deploy. Then monitoring, continuously monitor the deployed models performance and identify any issue or degradation in its predictions. This may involve tracking key metrics, analyze data drifts, and retain the model periodically. Okay, retrain the model periodically. The thing is, consider we are having a problem of hard disease prediction. Okay, today we are just well versed with our model and our model is performing great. Client is satisfied with it and we have deployed and we are giving it data and it's working fine. After 10 years, it is not the case, right? There going to be a possibility that the person who has a age less than 10, they're going to have a heart disease. Because I hope like everyone can accept this, the food habits that we are having today, right? It's not at all, I will say it is not at all close to who are doing in the olden days. They are eating a very healthy food. Now it is not. We are eating everyday fast food in some manner. Okay. So what I'm just trying to convey is that the model or data that we are training today for the heart disease prediction not going to work for the 10 years later. So you need to have a continuous monitoring of the system, whether it is predicting properly for whatever the data that we are giving on whatever the client need is. So you need to have a monitoring. Finally, model maintenance. Maintain the deployed model by addressing performance issue, updating the model with new data, or retraining it to improve its accuracy and relevance over time. This is what the same thing that we are doing. Okay, monitoring and maintenance is somewhat closer. So you need to make data that is model that is working fine for all the periods. Okay, we will not able to do that, but like we can fine tune it. Okay, we will say yeah, these are the things that is happening, so that we need to fine tune the model. That's not a problem, not a problem, because like the client can understand, because like you're gonna have a proper communication to the client that this is why I'm just churning the model, that is why I'm just monitoring the model. So you can explain the client can also understand. Okay, so this is what the model deployment and monitoring. So yeah, sir, over to you.
Yes. So model deployment and monitoring. So once we have done evaluation, we have done all model selection, training, tuning, all the processes, then we come here, model deployment and monitoring. Model deployment, you have to deploy the trained model into a production environment for real time or batch predictions, whatever. Choose an appropriate deployment platform. So a lot of people make mistake. They will not choose appropriate deployment platform and then they will have errors. They won't be able to deploy it properly based on the project requirements and scalability needs. Okay. Then we have monitoring. So continuously monitor deployed models performance and identify any issues, uh, any like any problem happening, any issues or degradations in its prediction. So it involves tracking key metrics, analyzing data drifts, or retaining the model periodically. So you have to ultimately monitor on the parameters, like whatever problem you're solving, your objective function. So is it giving you that performance? Is it giving you that kind of output? That is what is the parameter for monitoring. You need to understand that. Okay. And if it is showing some problems, so you have to train it well, or you have to fix those issues. Then maintenance, deploying model and addressing performance issues, updating model, new data, retaining, improving accuracy, relevance over time. So as Raja already explained that, uh, even I'll say in a year's time, technology changes and the data changes. Data is continuously changing, guys. Everything is changing. If you are observing everything, we were young, we became over, yeah, adult, we were born, everything is in a flux, in a continuous continuum, continuously changing everything. So if everything is changing, data is changing, models will change. So it's a constant thing. Change is the only constant thing. Okay. So according to that, your models will change. You have to keep eye, you have to keep improving, updating according to the time. So that is very important. Let's move to the other section.
Yeah, sure. So, yeah, okay. A final thing. I hope like this is the final thing that we're gonna have in this cycle of data science. I hope like the first thing and the last thing is gonna say what where you are collecting the data and what you're gonna communicate to the client. Okay. I love this thing very much because like this communicating insights and findings, it is like a art case. Okay, everyone cannot have this in their hand. So whenever you have a data, you should be in a manner that ready to convey the things to the client. Okay, actually sir has mentioned something. Okay, when you are able to convey the data to the kid or a child, then you are successful, guys. So you should have that much confidence of whatever the insight that you are getting and visualizing, the kids should be able to understand. Okay, let's see what is the communicating skills and findings. Visualization, so that's a major thing. Present insights and findings through clear and concise visualization such as charts, graphs, and dashboards. Use appropriate visual aids to effectively communicate complex data patterns and trends. Yes. Actually, we have just dedicated a session for this visualization. Please go through it. So the thing is, if you are having a data and you are just saying these are the tables, this is the numeric data, no, the client cannot understand. Okay, as a data science students and data science learners and data scientists, we can able to understand the data in a table form or numeric form. You need to make data very interactive, very visualized, so that the client can understand. You need to explain that what the data is to the client. Then a report and documents, create comprehensive reports and documents that summarize the project findings, methodologies, and results. Use a clear and concise writing style to ensure easy understanding. Guys, this is also very, very important. Okay. Once you have a data, you need to make it very interactive, very visualized, so that the client can understand. Yeah, guys, we are just talking about the communicating insights. So yeah, we are just talking related to stakeholder communication. Okay, uh, the thing is, whenever you have a data, right? So you need to be ready so that the data can be expressed from visual to the words to the client. Okay, the stakeholder communication is very important. That is a client communication. Communicate insights to the relevant stakeholders, including business leaders, domain experts, and data consumers. Tailor the communication style and level of detail to the audience understanding. So you need to make sure, yeah, these are the audience and this is how I need to communicate so that they can have a better understanding of what you have find. Okay, finally, feedbacks and iterations. Collect feedbacks from the stakeholders and incorporate it to the project. Iterate on the analysis model and communicate to the continuous improvement the project's value and impact. Feedback is a major thing, guys. We can do anything, but it should be come from the client. Okay, these are the things that you need to change, so we need to make this change, and that next time it should not happen. Okay, guys, I will say, actually I have just said, right, it is an art. You cannot learn using the session and this 5 minutes explanation. You cannot learn this art. You need to continuously practice it. You need to get the project, you need to get practice it, you need to just speak with the client, and you need to sit it, and you need to work, and you need to do everything in order to get this art. I will say data science is an art. This communication skill, it's like, I would say, more than an art, guys. Everyone cannot have it. Okay, so if you are having, you are just blessed. Okay, so yeah, so communicating insights and insights findings, it includes visualization. It should be very very understandable for everyone. Reports and documents, concise, precise, and crisp, so that others can understand. Stakeholder communication, you need to convey whatever the things that you are having to the client properly. Feedback and iteration. So once you are presenting to the client, you need to have a feedback out of it, and you need to explain them in a better manner for the next time based on the feedbacks and recover from it. Okay, so yeah, that's from my side. Yes, sir, over to you.
Yes. So communicating insights, guys, I've already given example that if you're able to communicate to a kid or a person who is not literate and you are 100% communicating according to them, so you're a successful communicator and you will be successful in life. That is a big skill, guys. So you have to put yourself 100% into others' shoes and see how they see the world, how they communicate, how they listen, how they see, how they understand. And that is the major part of a data scientist. So you have to use graphs, chart, all these things, tools, Power BI, Tableau, all these things for visualization, communicating through storytelling. And then you have to build report, document, summarize, with simple sentences, guys, simple English, very clear, no jargons in your statements, very simple, to the point, specific, step by step, with screenshots, with actual analysis, and then telling through stories. And then you have to communicate to stakeholders in their perspective, in the way they understand. Okay, and then feedback and iteration, continuously taking feedback and doing iterations, and this is how you will become a complete data scientist. Okay, and that is the real job. Like anybody can get insights and all, but communicating as per the other person's perspective, putting yourself in others' shoes with empathy, uh, realizing that the person is not data scientist, he's a normal person, he doesn't know numbers, math and stuff, algorithms and models. So you have to put to others' shoes and understanding all the limitations they have, and then communicate in a very artistic manner. Okay, like actors, if you've seen movies, um, complex stories, complex things, actors and directors, all these people communicate to audience in a simplistic manner. So you need to develop such skills as a data scientist. Let's move to the other section.
Yeah. So yeah, as sir has explained, this communication is like a skill. I'm again saying it's a skill and art. You cannot learn from the session. Okay, you need to just go for the project. You need to explain to the clients. Then you can get this art done. Okay. So yeah, this is what everything. I would say data and data science. We are just moving to the completion stage. I will not say we are moving into the stage where we are data and data science is gonna be full-fledgedly it's optimal. Okay, so this is what today's session. We're gonna have one more session which is on working with data. It is like a coding part we're gonna have. The next session is gonna be. So yeah, guys, this is what all about this session. If you guys have any doubts related to the session, please ping us in the comment section. And if you guys doesn't like subscribe to our channel, please subscribe to our channel and let us know if you guys are feeling any difficulties related to this data science field. So we are here to help you. So yeah, guys, that's it from my side. Like, thank you, guys. See you all in the next session. Bye, guys.
Yeah, guys, go and watch all the sessions 5 to 10 times and to reinforce learning, absorb the information, digest the information, apply the information, do all the assignments, then come to this session. Also, write feedback to us so that we can iterate and upgrade all these sessions and continuously upgrade. And also subscribe to our channels and also press the bell icon so that you will get notification and keep learning. So I'll give another insight for data science. So data is data. Science is including communication, finding insights, and communicating it to stakeholders. So from beginning till end, everything is data science. So give as importance as you will give to algorithm models. I think more than that to communication and communicating properly to stakeholders. So keep learning. Thanks a lot.